So in this segment, we want to prove a few trigonometric identities. These are the first two identities that we want to prove. Tan square plus cot square plus 2 is equal to sec square plus cosec square. And tan square plus cot square plus 2 is equal to sec square into cosec square. So let's take the first identity that is mentioned here. Tan square theta plus cot square theta plus 2. And I notice that in the RHS, I want sec square and cosec square. So I know that there is a way to convert tan square into sec square. Tan square theta, so the identity that I'm going to use is 1 plus tan square is equal to sec square theta. And 1 plus cot square theta is equal to cosec square theta. So therefore tan square theta can be written as sec square theta minus 1 and cot square theta can be written as cosec square theta minus 1 and then have a plus 2 here. So now this becomes sec square theta plus cosec square theta and minus 1 becomes minus 2 and then there's a plus 2 there. So minus 2 plus 2 cancels. Therefore, this becomes sec square theta plus cosec square theta, which is exactly what I wanted in the RHS. So what I did in this problem was I converted the tan square into sec square and I converted cot square into cosec square, and that is how I got my answer. Now an alternate way to think about the same question is that this 2 can be split as 1 and 1. So what we can do is I can write this as tan square theta plus cot square theta and 2 can be split as 1 plus 1. Now 1 plus cot square becomes cosec square and this tan square plus 1 becomes sec square, right? So that is another way of solving the same question where the same set of identities are used. Now let's see how we can prove the next identity, which is tan square plus cot square plus 2 is sec square into cosec square. Now I can treat this identity as an extension of the identity that we already solved. So let's just continue. One thing that I notice is I have two terms right now and the final answer that I want has just one term. So I have to merge the two terms, which means I have to find the LCM to merge the two terms. So sec square can be written as 1 by cos square theta and cosec square can be written as 1 by sin square theta. So now I can take the LCM and merge, right? So I get the LCM is therefore sin square theta into cos square theta and the numerator is sin square theta plus cos square theta. Now sin square plus cos square is 1, therefore this becomes 1 upon sin square theta into cos square theta and this becomes 1 by sin square theta into 1 by cos square theta. 1 by sin square theta is given by cosec square theta and 1 by cos square theta is given by sec square theta. So addition of sec square plus cos square is therefore equal to multiplication of addition of sec square and cosec square is equal to the multiplication of the same two terms. So this is what we showed in this particular identity. I'll pause for a couple of minutes for you to check what was done and then I'm going to continue. There's another way to solve this question, by the way. Let me show that method also before I pause. So what I'm going to do is I'm going to convert everything into sin square and cos square right from the first step. Okay. And let's see what identities tan square can be written as sin square theta upon cos square theta and cot square theta can be written as cos square theta upon sin square theta plus 2, right? So now I can find the LCM of these three terms. The LCM is cos square theta into sin square theta. Sin square will get multiplied by sin square, so it becomes sin raised to 4 theta. Cos square gets multiplied by cos square, so it becomes cos raised to 4 theta. and then I have 2 sine square theta cos square theta. So therefore, this is now of the form a square theta cos square theta, and cos raised to 4 is basically cos square theta the whole square, the whole thing divided by cos square theta into sine square theta. And now this is the numerator is of the form a square plus 2ab plus b square, which is basically a plus b the whole square. If you notice, I have a square term here, I have a 2ab term here, and I have a b square term here. So this is a plus b the whole square divided by sine square theta cos square theta. Now sine square plus cos square is 1 in the numerator, so this is 1 upon sine square theta cos square theta, and therefore the answer is cosec square theta into sec square theta. This is the final answer. So there are a few techniques that were used in this particular question. One was using sine raised to 4 plus cos raised to 4 plus 2 sine square cos square as sine square plus cos square the whole square. And if I want to merge the terms, then using LCM is a great way to merge the terms. So these are the two things that I observed in this question. Now let me pause for a couple of minutes for you to take a look at this strategy. Okay, let me now continue with the next question. Okay, so let's look at the left hand side. I have cosec a minus cot a the whole square plus 1 divided by sec a into cosec a minus cot a. So what I'm thinking of is, of course, a minus b the whole square is one definite technique that I should use in the numerator, and cosec a minus cot a is most likely going to get cancelled because I want 2 cot a. So 2 cot a basically means 2 cos a by sin a. So just in my mind, I have noted down that the RHS is actually 2 cot a, which is 2 cos a by sin a, right? This is what I should eventually reach to prove the given identity. Okay, so let me start with the left hand side. I have cosec a minus cot a the whole square. Let's expand a minus b the whole square. That's a square minus 2ab. So minus 2 cosec a cot a plus b square. The whole divided by, b square will be cot square a. And then there's a plus 1. The whole divided by sec a into cosec a minus cot a. Now let's think of some simplifications. I notice that 1 plus cot square, there's a simplification possible. I know that 1 plus cot square is cosec square. So cosec square a minus 2 cosec a cot a plus 1 plus cot square can be written as cosec square a, right? The identity used here is 1 plus cot square is equal to cosec square. The whole divided by sec a into cosec a minus cot a. Now cosec square plus cosec square becomes 2 cosec square a minus 2 cosec a cot a, right? Divided by sec a into cosec a minus cot a. I can definitely take something common in the numerator. In the numerator, 2 cosec a is common. So 2 cosec a is taken out as common, and cosec a minus cot A is left inside. See, the technique of factorization is going to help me simplify the terms greatly, right? And the denominator is sec A into cosec A minus cot A. Now cosec A minus cot A cancels from both numerator and denominator, which is why I was not opening up the brackets in the denominator, right? I wanted that cosec A minus cot A to vanish. So this becomes 2 cosec A divided by sec A, and now I can write this as 2 times 1 by sec A is cos A and cosec A is 1 by sin A. So the places just get shifted. Cosec A becomes sin A in the denominator and sec A in the denominator becomes cos A in the numerator. And therefore this becomes 2 cot A, which is the RHS that we were expecting. So this is how I solved this particular question. Techniques used here were A minus B the whole square, merging the terms together and not opening up the brackets and waiting for simplification to happen. So again, let me pause for a couple of minutes for you to take a look and then we'll continue with the next one. Okay, let's continue with the next question now. Okay, so this is the next question that we have. I'm going to use a different technique in this particular question, which we have not done yet so far. I'm going to take both the left hand side and right hand side and I'm going to simplify both the sides, okay, and then show that both sides are equal. So let's take the left hand side. The left hand side is 1 plus sec theta, 1 plus sec theta divided by sec theta. Let's convert everything to sine and cos because the right hand side contains everything in sine and cos. So this is 1 plus 1 by cos theta, or I can think about splitting the numerator also. That's a better idea, I guess. So let us split the numerator. What I mean by that is I can write this as 1 by sec theta plus sec theta by sec theta. Okay. So 1 by sec theta becomes cos theta and sec theta by sec theta becomes 1. So let's leave this as the first result. Now let's go to the RHS. So in the RHS, I have sine square theta. By the way, the LHS now has only cos theta. So I am now going to think of what can be done to convert this sine square into a cos term. And the immediate response is, I can write this sine square as 1 minus cos square theta divided by 1 minus cos theta. So what identity was used here? Sine square theta plus cos square theta equal to 1 was the identity used over here. Now this is of the form a square minus b square. A square minus b square can be factorized as a minus b into a plus b. So 1 minus cos square theta can be written as 1 minus cos theta into 1 plus cos theta, the whole divided by 1 minus cos theta. So now what happens is 1 minus cos theta, 1 minus cos theta cancels and my RHS is also 1 plus cos theta, which means my LHS equals RHS and hence I have proved the given identity. So in this particular problem, I exhibited a different type of technique in which you take both the LHS and RHS, you simplify both the sides and bring them to a common point. Now suppose you didn't want to do this and you wanted to just show that RHS is equal to the LHS. Then what could have been done is, so let's forget the LHS for the time being. Okay, I got 1 plus cos theta. Now suppose I want to take this to the LHS. So LHS contains sec theta, right? So I don't want this cos theta, I want sec theta. So I will write this cos theta as 1 by sec theta. Finding the LCM, I get sec theta plus 1, the whole divided by sec theta. And that is equal to my LHS. So this is another way by which you can solve the same problem. Okay, let me pause again for a couple of minutes and then I will take up the next one. Okay, let's continue with the next question. Okay, so this is the next question that we have. We have 3 parts over here. The first part is sine square a by cos square a plus cos square a by sine square a is equal to 1 by sine square a cos square a minus 2. And then the second part is proving that. So the second part is quite easy. So I want to prove that 1 by sine square a cos square a 1 by sine square a cos square a minus 2 is equal to sec square a cosec square a minus 2. Now this is quite easy. I can start with the LHS. I have 1 by sine square a into cos square a minus 2. So this becomes 1 by sine square a into 1 by cos square a. 1 by sine square a into 1 by cos square a minus 2. So 1 by sine square a is cosec square a and 1 by cos square a is sec square a. So this becomes cosec square a into sec square a minus 2. So I have proved this particular part, right? Now I need to prove the LHS equal to the RHS in the first part. So now I have to prove that sine square a upon cos square a plus cos square a upon sine square a is equal to 1 by sine square a cos square a minus 2. So I'm going to use some important ideas in this question. So pay close attention. Let's start with the left hand side. Sine square a by cos square a plus cos square a by sine square a. On taking the LCM, I get sine square a multiplied by cos square a. And if you look at if you take the LCM, it's going to be sine raised to 4a plus cos raised to 4a. Now, one important thing is the denominator is sine square a plus sine square a into cos square a on the RHS, and it is also sine square a into cos square a on the LHS. So I think that's a good sign. It is a very subtle hint that maybe we are proceeding in the right direction. Now, sine raised to 4a is sine square a the whole square plus cos raised to cos square a the whole square, the whole divided by sine square a cos square a. So now let's see what needs to be done. The other day when we were discussing about the expansions, we said that, okay, let me mark a box here and write it there. The other day we said that if I have a square plus b square, we noticed that there was a way to deal with the formula. So a square plus b square plus 2ab is given as a plus b the whole square. And this therefore means a square plus b square is a plus b the whole square minus 2ab, right? This is the formula that I have. And therefore, I can write this as, this is my a and this is my b. So a is sine square a and b is cos square a, right? So I can write this as a plus b the whole square. So a is sine square a and b is cos square a the whole square minus 2 times sine square a times cos square a the whole divided by sine square a cos square a. Now sine square plus cos square is 1. So 1 minus 2 sine square a cos square a the whole divided by sine square a cos square a. And this therefore becomes, if I split the numerator now, what I will get is, I will get 1 by sine square a cos square a minus 2 sine square a cos square a by sine square a cos square a will be simply 2. So this is how I prove the first part. One important technique that I used over here is, whenever I see sine raised to 4 plus cos raised to 4, I should definitely think of the technique that I used in this particular solution. Okay. So again, I'm going to pause for a couple of minutes and you can take a look at how it was done, and then we'll continue with the next question. Okay, let us now continue with the next question. Okay, so in this question, I noticed that I have 1 minus 2 sine square a the whole square in the numerator, and I have cos raised to 4 minus sine raised to 4 in the denominator. Definitely, I can use the technique of a square minus b square in the denominator. That is going to help me. And I noticed that in the answer, I don't have a sine square anywhere. I have only cos square. So maybe there are a few things that I should be doing. In the numerator, let me get rid of the sine square. I know how to convert sine square into cos square. I can take the LHS and I can say that in the LHS, I have 1 minus 2 sine square a the whole square divided by cos raised to 4 can be written as cos square a the whole square minus sine square a the whole square. Now in the numerator, I don't want a sine square term because the RHS contains only cos square. So I'm going to make that change in the numerator. I'm going to write it as 1 minus 2 times sine square A is 1 minus cos square A. I have made that substitution because the identity is sine square A plus cos square A is equal to 1. And in the denominator, I can use the idea of A square minus B square, which is A minus B into A plus B. And I know that cos square A plus sine square A is 1. So this particular term that I have, this is going to become 1. Okay, so I am now left with, let's look at the numerator. I have 1 minus 2 times plus 2 cos square A the whole square divided by cos square A minus sine square A. So now let me write the numerator. Numerator is 2 cos square A minus 1 the whole square, and in the denominator I have cos square A minus sine square A. Now what comes to my mind is in the RHS there is no denominator, or rather the denominator is 1. So is it possible for me to convert the sine square A I have in the denominator into a cos square A, hoping that something will simplify? So I have 2 cos square A minus 1 the whole square divided by cos square A minus sine square A can be written as 1 minus cos square A. So this becomes 2 cos square A minus 1 the whole square divided by cos square A minus 1 plus cos square A. See, after opening up the brackets, minus into 1 became minus 1 and minus into minus cos square A became plus cos square A. Therefore, this is 2 cos square A minus 1 the whole square divided by 2 cos square A minus 1. Now the numerator contains 2 cos square A minus 1 the whole square. Denominator contains 2 cos square A minus 1. Therefore, the result is going to be 2 cos square A minus 1, which is basically my RHS. So, LHS is equal to the RHS is proved in this particular problem. Again, I'm going to pause for a minute and then I'll continue. Okay, let us now go to the next question. So take a look at this particular question. We have cosec A minus cot A. In the RHS, we have sin A upon 1 plus cos A. So let us now see how to take this particular problem. I noticed that I can start with the LHS, with the RHS, or I could even do with the LHS. So RHS is sin A divided by 1 plus cos A. Now what comes to my mind is I am going to rationalize the denominator, that is multiplied by 1 minus cos A, the numerator as well as denominator. So therefore this becomes sin A into 1 minus cos A divided by 1 plus cos into 1 minus cos is 1 minus cos square A, which is therefore equal to sin A into 1 minus cos A, and 1 minus cos square A can be written as sin square A, right? So the identity that I used here is sin square A plus cos square A is equal to 1. Now 1 sin A cancels from the numerator, 1 cancels from the denominator. So I am left with 1 minus cos A by sin A, and I can consider splitting the numerator. So it is 1 by sin A minus cos A by sin A, which is therefore equal to cosec A minus cot A. And this is my LHS. Therefore RHS equals LHS. Now let me show you a way by which I can even convert my LHS to RHS. So let's see how to go from LHS to RHS. Let's start off with the term in the LHS. So my LHS is cosec A minus cot A, and cosec A is basically 1 by sin A, and cot A is cos A by sin A, right? Therefore, this becomes 1 minus cos A divided by sin A. Now let me pause for a couple of seconds and think. See, the RHS contains 1 plus cos A in the denominator, right? So I am just going to multiply with 1 plus cos A, the numerator as well as denominator. So let's see what happens. 1 minus cos into 1 plus cos becomes 1 minus cos square A divided by sin A into 1 plus cos A. Now 1 minus cos square A can be written as sin square A divided by sin A into 1 plus cos A. Now sin A cancels, and therefore I get sin A divided by 1 plus cos A, sin A divided by 1 plus cos A, which is my RHS, right? So in this second method, I started with the LHS and I reached the RHS. In the first method, I started from the RHS and I reached the LHS. So I will give you a couple of minutes to grasp both the methods, and then we will continue with the next problem. Okay, let's continue with the next question. Okay, let's take a look at this particular question. Sec raised to 4a into 1 minus sine raised to 4a is equal to 1 plus 2 tan square a. This is the question. So now, what I notice is I can start off with the LHS. Okay, let me start off with the LHS. I have sec raised to 4a and then I have 1 minus sine raised to 4a. So first of all, the RHS contains only tan square a. So there should be a method by which I should be able to convert these terms into that tan square a term. But let's take it one step at a time. I know that sec raised to 4 can be written as sec square a into sec square a. And 1 minus sine raised to 4 can be written as 1 square minus sine square a the whole square. Right? So 1 square is 1 and sine square the whole square is sine raised to 4. So now I notice that I can use a square minus b square, which is sec square a into sec square a into 1 plus sine square a multiplied by 1 minus sine square a. So now let's see what happens. I get sec square a into sec square a. 1 plus sine square a, I can't do anything with it. So let me leave it like that. But 1 minus sine square a, I can write it as cos square a. So the way I would write the solution actually is, I would explain all the identities that were used. So here a square minus b square was a plus b, a minus b. And here I have used the identity sine square a plus cos square a is equal to 1. Right? So in your trigonometric identity solutions, you will have to mention the different identities that you are using. Now I know that sec square into cos square is 1. So these two terms will cancel out each other. The reason is I can write this as sec square a into this sec square a can be written as 1 by cos square a because sec is 1 by cos into 1 plus sine square a times cos square a. So what was the identity used here? I used the identity sec a is 1 upon cos a, right? And now again cos square a would cancel. So I am left with sec square a into 1 plus sine square a. Let me open the brackets. This becomes sec square a plus sec square a into sine square a into sine square a. So now I can definitely convert this sec square a into 1 plus tan square a, 1 plus tan square a, and this sec square a I can write it as 1 by cos square a times sine square a. So this becomes 1 plus tan square a, and sine square a by cos square a also becomes tan square a. Therefore I get 1 plus 2 times tan square a. So this is my RHS, hence proved. What were the different techniques that were used in this particular solution? First of all, I used a square minus b square. So whenever I see raised to 4 and the subtraction sign, this should come to my mind that a square minus b square is possible. I also used sec is reciprocal of cos, and then I converted everything into the form of tan square a. So this is how I reached the solution. Again, pausing for a few minutes. Okay, let's continue with the next question now. Okay, let's consider the following identity. In the LHS, I notice 1 minus cos and 1 plus cos as the denominator. So finding LCM is going to be a great idea because it is going to make the LCM 1 minus cos square, which will become sine square eventually. So that's a good idea to start. So let's take the left hand side. Okay. So in the left hand side, I have sine theta upon 1 minus cos theta plus tan theta upon 1 plus cos theta. What is the LCM? The LCM of the denominator is 1 minus cos into 1 plus cos. 1 minus cos theta into 1 plus cos theta. The numerator becomes sine theta into 1 plus cos theta. And the second part of the numerator becomes tan theta into 1 minus cos theta. Right? And the denominator is 1 minus cos into 1 plus cos. So when I open the brackets, I get sine theta plus sine theta cos theta, sine theta cos theta, plus tan theta into 1 is tan theta, minus tan theta cos theta, right? This is what I get. The whole term divided by, I now get 1 minus cos square theta. And now I know that the denominator definitely can be written as sine square theta because the identity that I will use is, so the identity that I'm going to use here is sine square theta. So the numerator is now sine theta plus sine theta cos theta plus tan theta minus, now let's see what happens to tan theta by cos theta, okay? So let's write this tan theta as sine theta upon cos theta into cos theta. So cos theta cancels, so I'm left with minus sine theta. So let us write our numerator now. It is sine theta plus sine theta cos theta plus tan theta minus sine theta, the whole divided by sine square theta. In the numerator, you will notice that sine theta minus sine theta cancels. So I am left with sine theta cos theta plus tan theta upon sine square theta. So let us split the numerator now. It becomes sine theta cos theta upon sine square theta plus tan theta upon sine square theta. Now sine theta cancels. So this becomes cos by sine becomes cot theta plus tan theta is sine theta upon cos theta into sine square theta. So sine theta also cancels and therefore this becomes cot theta plus sec theta cosec theta, which is basically my RHS, right? Therefore, I have proved LHS equal to RHS. A few techniques used here were first finding LCM. I jumped at that idea because I saw 1 minus cos square coming up in the denominator, and then I converted the tan into sine by cos, and that led to a few simplifications. And then I simply split the numerator, and I was able to convert everything into sine and cos, and I got my RHS. So again, I'm pausing for a couple of minutes. Take a look at what was done, and then we will continue with the next question. Okay, so these are the only identities that I wanted to discuss in this segment. Let us discuss some more identities in the next segment.